All right, we're going to look at this question from homework. It wanted you to find each of the following probabilities if the probability that Apple stock rises is 37.2%. And, oops, that was weird. I don't know why that did that. And the probability that the Samsung stock rises is 41.3%. And so the first part of this said that the probability that either event A or event B occurs if the two events are independent. So if they're independent, then we're saying that they do not depend on each other. And so the probability of A or B happening is just the probability of that A plus the probability of that B minus the probability of A, B happening. So we have, I'm going to write them all in decimal form because it said that it wanted our answers to be 4 decimal places. So moving these, converting those into decimals would be 0. We're going to call this event A and that event B. So event A is 0.372 plus 0.413 and then minus their intersection. Not really the intersection, but that both of them do happen because they're independent. But the probability they both happen, we would multiply 0.372 times 0.413, which will be, punch it into my calculator, 0.6314. I just rounded that last digit. All right, so then the next part is the probability that event B does not occur. So the probability that event B does not occur is really just asking for the complement. So we're going to take 1 minus that 0.413. And so when we do that, 1 minus 0.413, it'll be equal to 0.857. The next question is that the probability that both event A and event B occur if the two events are independent. Well, we already said that up above, that the probability of both of them happening is just going to be the product of them. And so if we multiply that 0.372 times 0.413, it's going to be equal to 0.1536. Okay, the next part that we have is the probability that either event A or event B occurs if the two events are dependent. And the probability that both occurs is 17.4%. And so if they're dependent, it's making me really want to draw a Venn diagram to think about the situation. And so the probability of both would be that 17.4%. And we know that the total for part A is 0.372 and the total for B is 0.413. So I need to subtract off that intersection part. So 0.372 minus 0.174, we're going to get 0.198 here. And if we subtract the 0.413 minus that intersection, 0.413 minus 0.174, we're going to be at 0.07. That's not right. Let's see. That's too small. Let's see. So we're doing 0.413 minus 0.174 gets us 0.239. Okay, so then to answer the question that the probability that event A or B occurs, so we just basically can't double count because they are dependent. We're going to double count that 17.4, and we took into account that there was that they were dependent. So we're just going to add really the 0.198 plus 0.174 plus 0.239. And when you add all of those together, 0.198, 0.174 plus 0.239, we get 0.611. So again, that was the probability that A or B happened, knowing that they were dependent with that intersection. So then we have the probability that event A does not occur. So we want A to not occur. So we're looking at the probability of that complement, really. and event B does occur, so we want the probability of the complement of, of A, and we need B to occur. So the probability of that is going to be looking at the probability of the A complement times the probability of that B happening. So the complement of A, remember that A was 0.372. Again, we're dependent, but I'm just looking at that 0.372. So A would be 1 minus that 0.372. That would be the probability of A complement. And then times the probability of B, so 0.413. This ends up being 1 minus 0.372, so 0.628 times 0.413. This will be equal to 0.2594.